Good afternoon, everyone. It's my pleasure to speak today about improvement of dental implant design using finite element method. As was mentioned before, my name is Agata Mrozek and I work as simulation engineer in Bootsoft. And this presentation was prepared together with my colleagues from Bootsoft, Marcin Wierszycki and Krzysztof Szajek. The presentation is divided into four sections. I would like to start with a short introduction to the topic of implantology in dentistry and explanation of our motivation. Next, I will present computer-aided design process of tooth implant, and the key part of this presentation will be focused on applied finite element model and possibilities to improve the design of dental implant using finite element analysis. And I will sum up with short conclusion. So dental implantology is a complex specialty which aim is to deal with the permanent implantation of artificial teeth. This area of interest is located in the intersection between medical and engineering sciences, and many factors must be taken into account in order to increase the probability of successful treatment. Dental implants are expected to be serviced as long as they are able to fulfill biological, aesthetical, and functional requirements, and including engineering tools like finite element analysis in the life cycles of implant could improve the quality of dental implants. So firstly, let me give you some background information about implantology in dentistry. Dental implants restore missing teeth not only in the aesthetic aspects, they also restore a person's ability to chew. The role of natural root is fulfilled by the implant fixed in the bone. The abutment is usually attached to the implant by the abutment fixation screw. The most visible part of the dental implant is ceramic crown, which resembles the natural occurring enamel. The example of dental implant system is shown on the slide, and it consists of three parts: abutment, screw, and fixture. And it's made of medical titanium alloys like grade 4 for fixture and grade 5 for abutment and the screw. The next section outlines the motivation to explore the topic of improvement of dental implant design using finite element method. Dental restoration with the application of dental implant are very effective and commonly used in dental treatment for over the last 50 years. Unfortunately, for more than 50% of patients, diverse complications can be observed. They are biological and mechanical. The biological complications are, for example, lack of osseointegration or bone breaking. From the viewpoint of implant mechanics, the most common reason of treatment failure is loosening of screw, and it was observed for over 50% of patients. The failure was also caused by the micro-cracking and fracture of the implant. On the slide, the example of failure in the implantation process are presented. On the left picture, there is implant before fracture. On the right side, damaged implant is visible. It is important to prevent these causes because the final success of dental restoration procedure depends on global tooth implant life. Dental implants, as any product, need constant development in order to compete and survive market competition. And these developments are mostly driven by problems occurring during utilization and implantation process. And it is supported by computer-aided design and computer-aided manufacturing tools. So now let's move to the applied finite element model. The implant geometry was simplified to axis symmetric representation. Applied sketches were prepared on the basis of full 3D model of the dental implant system. And based on the sketches using revolution option, axis symmetry model were created. Simulation of tightening is crucial for mechanic behavior of implant, and it involves complex contact interaction. And the contact between several surfaces has been defined, and it is implant body and screw thread, implant body and abutment and screw head. Applied finite element mesh consists of two types of elements: hexagonal and cylindrical element. And compared to hexagonal elements, cylindrical elements enable the use of coarser mesh. It results in reduced calculation time. Although cylindrical elements effectively simulate the general response of the system, it does not provide the accurate result in the load plane, when the highest stresses are expected. Due to this fact, the additional section of solid elements is introduced close to the load plane, and the section is constructed with 4 layers with an angle of 2 degrees. Dividing the hexagonal element section into several layers is a result of observed stress disturbances at the cylindrical hexagonal element interface. It was experimentally proved that if 4 layers are present, the disturbance did not occur in the layer in the load plane. The combination of cylindrical and hexagonal elements provides both cost-effective and accurate results in the crucial region of the system. Applied finite element mesh consists of significantly lower number of elements. The presented approach enables us to significantly reduce the time of calculation. The simplified model gives us the same results as equivalent fully 3D model, and the calculation time was reduced by 10 times. Two types of applied boundary condition can be distinguished. Firstly, the moderate osteointegration level was taken into account. 3 mm bone loss was assumed. Additionally, the symmetry condition was also considered, applied to the symmetry plane of the system. The implant model loads were applied in 2 steps. First, tightening and then loading of the dental implant system. The first step is simulation of tightening. Tightening was simulation by applying an axial force to the middle part of the screw. The second step is loading of the implant. Horizontal and vertical loads are applied to the tip of the abutment using kinematic constraint. Optimization of manufacturing process and properties of dental implants is possible at both the product design and manufacturing planning stages. Due to the topic of presentation, we will focus on possibilities of improving implants using finite element analysis. Obtained results from analysis enable us to evaluate the fatigue life of certain components of dental implant system. The influence of geometric parameters on the obtained fatigue life was studied. In the presented study, several independent geometrical parameters are defined. All of them refer to the upper part of the implant and consider both angular and linear values. The sketch was parameterized in order to conduct geometry modification, and number of geometric constraints are applied in order to control an effect of geometry modification. Their fundamental function is to prevent unintended changing, leading to the unphysical geometry. The fatigue life calculation used a procedure based on Guzman theory and Baskin equation, and the number of cycles to fracture was calculated using formula presented on the slide. On the next 2 slides, the influence of selected geometric parameters of the obtained fatigue life will be presented. First parameter, E, hexagonal slot height. On the slide, the influence of the hexagonal slot height represented at horizontal axis on the obtained number of cycles to fracture vertical axis was prepared. For all analyzed range of hexagonal slot height, the most durable component of the dental implant system was abutment. The number of cycles to fracture was strongly dependent on the value of this parameter, and as the value of this parameter increases, the fatigue life of the system improves. There is a certain value for which the weakest part of the system is the implant, which is not beneficial from the point of view of patient safety. Next parameter, B, screw head conic surface opening angle. So regardless of the value of this parameter, the weakest component of the system was the screw, while the most durable component was abutment. The B parameter had a greater impact on fatigue life of the abutment, while it did not significantly affect the fatigue life of the fixture. Last selected geometrical parameter is hexagonal slot conic surface opening angle. On the slide, the influence of the hexagonal slot conic surface opening angle represented at horizontal axis on the obtained difference between the loosening moment after tightening and after loading included on vertical axis was presented. And it is parameter that determines the loosening moment drop. The bigger the value of the angle, the lower the loosening moment drop was observed after implant loading. And the change of this parameter allows to reduce the value of loosening moment drop by more than 90%. The study of geometric parameters of the implant system was conducted at the design stage. However, not only the design of the implant affects its fatigue life. The assumption about the implantation procedure, to be more precise, the applied tightening moment, is also a relevant factor influencing the obtained fatigue life. The guideline how to safely and effectively tighten the screw is a crucial issue from the perspective of final dental implantation process. Tightening was simulated by applying to the middle part of the screw the axial force, which corresponds to the certain tightening moment, and different levels of screw preload were analyzed. The screw load optimality in the context of fatigue fracture was considered. On the slide, the influence of axial force which corresponds to the certain value of tightening moment represented horizontal axis on the obtained number of cycle to fracture vertical axis was presented. And the number of cycle to fracture of the abutment is independent of the screw preload. Nevertheless, the higher the preload level, the lower the value of fatigue life of both screw and fixture. And this component's durability are strongly dependent on the applied tightening moment. There is a certain value for which a change in the weakest component of the system has been observed. The weakest part of the system becomes the implant. When applying a load with a horizontal component, the abutment always proves to be most durable component of the system. Nevertheless, when only the vertical component acts as the system, for smaller values of the tightening moment, the abutment is the weakest component of the system. Only when the value of the tightening moment is significantly increased, does it become the most durable component as a result of significant decrease the fatigue life of the fixture and the screw. The slide shows the Pareto front obtained for the defined cost function. On the horizontal axis, the number of cycles to fracture is presented, and on the vertical axis, the value of loosening moment after loading is shown. The applied preload level significantly affects the fatigue life and the magnitude of screw loosening moment. The higher the value of screw preload, the more resistant the implant is to loosening. An increase in fatigue life results in a decrease in the value of loosening moment. On the horizontal axis, the number of cycles to fracture is presented, and on the vertical axis, the value of loosening moment drop after loading is shown. Only cases in which the horizontal component of the force was applied are considered. When only the vertical component was applied, the changes in the loosening moment reach very small value, and the change did not exceed 2%. The correlation between the fatigue life and the value of loosening moment drop is negative and nonlinear. It is possible to increase the number of cycles to fracture while reducing loosening moment drop. In conclusions, let me sum up my main points. Firstly, screw preload has significant influence on fatigue life and loosening moment value. The higher the value of the screw preload, the more resistant the screw is to loosening. However, increasing the screw preload value results in a decrease in fatigue life. And not only the tightening moment, but also geometric parameters significantly affects the amount of fatigue life of the system. and the guideline how to safely and effectively tighten the screw is a crucial issue from the perspective of final dental treatment success. Thank you for your attention. If anyone has any question, please write it on the chat.